All right, now let's talk about another type of variation, which is.
Oh, jeez. Oh, jeez.
Which, calm down there. I know you're excited about here. This is joint variation. This is not puff puff pass variation. This is joint variation, and you're going to see something. You're going to see something like this: that y varies jointly with x and z. See, here's the thing. We're not just talking about a relationship between y and x. We're talking about a relationship between y with x and z. So when it varies jointly, does someone say really, like, oh my gosh, like, no way? I'm like, yes way, because like when you look at the stuff, you've like totally seen the stuff before. You just like don't remember it. Let me give you an example, all right, Angelica? All right? Nobody knows this shoe. There are a lot of Angelicas out there. Lo siento mucho. The area for a triangle is 1/2 the base times the height. Is it not?
Yes.
Most depth?
Yes.
Now, yeah. Word. But look what's going on here. The area of a triangle varies jointly with the base and the height. That means if the base increases and the height increases, then what do you know about the area? That's going to increase as well. So the area is tied not to just one piece, but to two pieces. As they go, area goes. All right? And what's the constant that connects these guys together? The 1/2. Okay? We might talk about the volume of a cylinder. The volume of a cylinder is pi r squared h. Okay? So this guy right here is your k. R and h are the variables that are associated with the volume of a cylinder. Okay? So when you look at your cylinder, here's your height, and there's your radius. So the volume is completely dependent on your radius and the height of that can, right? If you increase the radius, if you increase the height, what does that do to your volume? It's going to increase that, right? And it's all going to be based on the relationship, it's all going to be based on the relationship that we have here in this formula. What do you guys think? So have you seen variation in the real world before? Yes? You see it when you pump gas, the more gallons you put in your car?
The more you pay.
The more you pay. The price per gallon is going to be the constant that ties your gallons to your purchase price, right? What do you mean your weight? What do you mean weight? The more you weigh, the bigger your clothes get. Okay.
Some people don't buy their clothes.
You know what? Sometimes we're trying to save money. Here's an example of inverse variation. We did these word problems yesterday, right? Ruth and Esther and Isaac and Rebecca, they're all painting and doing stuff, right? If we're painting a house, for example, if we increase the number of workers painting a house, what should that do to the overall time?
Decrease.
It should decrease that, right?
Yes.
So 3 years ago when I was putting my house on the market, I had a painting party at my house. Had about a dozen or so people. We painted the entire house in 4 hours. All the walls and some of the ceilings in 4 hours. Of course, I paid them in $5 pizzas, so it kind of worked out. But if it had just been me and my wife painting the house,
Oh my God.
it would have taken a long time, right? Now, when you have problems like that, the constant of variation that ties those together is what we call man-hours, right? If there's a particular project that takes 60 man-hours, that means it would take one person, what? 60 hours to do that. But if you increase the number of people, that means the total time is going to do what? Decrease. That's a real-world example of inverse variation. And you guys know this. You know a lot of times that the more help you have, up to a certain amount, the less time it's going to take, right? Now, of course, if you're trying to paint a room and you have 50, like in this room, if you had 50 people painting in this room, you're just going to be in each other's way and you can't do anything. So understand that there are optimal levels for a lot of this stuff. There's one more kind of variation that I want to talk to you about, and it's called combined variation. You might want to go ahead and keep that open. Someone may need to borrow a piece of paper later. Yes, Connie? Well, I guess you could have just one of these guys changing. But it's going to be difficult to say if the base goes up and the height goes down, what does that do to the area? It's going to be very difficult to say if the area goes up or down. Okay. Now, since these guys are both the same power, if you were to double the base but cut the height in half, that's not going to affect the area at all.
What if the height stayed the same?
If you just increase the base but don't touch the height, then of course the area is going to go up.
So both don't have to change this one?
Right, they don't both have to change. Now, if we talk about something here, this guy is r squared and this is h, then the relationship about how they change is going to be drastically different from them being both linear factors. Okay, but really it's just a way, and just trying to show you the relationship that the area is connected directly to those. That means if one goes up, area goes up. If one were to go down, area goes down. Okay. Now combined variation is a little bit different. Combined variation, you'd see something like this, that y varies directly as x and inversely, and inversely as z. Y varies directly as x and inversely as z. So basically what we're doing is we're combining both direct and inverse variation in the same expression. And how do you think this guy would look? How do you think you would do just this first part here, where it says y varies directly as x? What did we say for direct variation?
It's going to be k times y?
No, it's going to be k times x.
Oh, sorry, x.
And how would you express inverse variation with z?
Divided by z.
Right. And so what we're saying here in this example is that as x goes up, what's y going to do?
Increase.
As x goes up, y goes up. And as z goes up, what's going to happen? Y is going to go down. So y varies directly with one variable, but it has an inverse relationship with the other guy. Okay. So we're going to work through some examples so you can see how variation is used. And hopefully this will help clear up some questions that you guys may have.